Hi, this is Bill Punch. This video is one of a series of videos used to support Michigan State University's Introduction to Computer Science using Python CSE 231. This particular video will cover the logical operators in sequence with the relational operators we just covered. Let's get started. The second set of operators are called logical operators, and you've probably seen these before as well. These are the operators not, and or. And you probably saw these that look something like this. We measure two values, P and Q, and the various combinations of true and false, and then we show the results for the not operator, the and operator, the not operator here, the and operator here, and the or operator here. So for the combination of P equals true and Q equals true, measuring not P, not inverts the value from true to false, and that's true all the way down. True here, false there, false here, true there, false here, true there. Just what you'd expect. For the AND operations, you remember how AND works. You get a true on AND if both of the elements are true. Otherwise, if one or more of the values are false, then you get a false. For OR, it's the opposite. The only time you get a false operation on the ORing of two values is if they're both false. Otherwise, a single true is enough to give you a true value. So you can not a single value, you can AND two values together, or you can OR two values together to get the results you were just seeing. It turns out that chain comparison is in fact exactly equal to the AND of these two things. So before I had said, is it between 0 and 10? I could have actually said, is it less than 10 and is it greater than 0? Gives me exactly the same result. True. I can do an OR. Remember, one true is all one needs for an OR. So is my int now 7 less than 10? It is. It doesn't matter what the next one does. That comes out true. My int is equal to 7. If I say the not of that, it was true. Now false. Interestingly, Python allows for a broader range of values and comparisons with the and, the or, and the not operator besides the capital T true and capital F false. The way it essentially works is that for every type, there's exactly one sort of, and I call it an empty value. So each type has one of those empty values, and the empty value is a stand-in for the value false, whereas every other value in that type is equivalent for true. So for example, false in an integer, the empty value is 0. False in a float, the empty value is 0.0. False in a string, the empty value is the empty string. So there's exactly one value in every type that's empty, that's false. Otherwise, those values are stand-ins for true. So it's easy to remember the false values. That's taken into account in the following way. Remember when we ran this example up here, I said that it was good enough to get one true operation on an OR, and it really didn't matter what happened here because one true is good enough to make this entire expression true. Python tries to pay attention to that and says, look, when I'm evaluating an operator, if I know what the answer is at some point in the evaluation, then I'll return the value that gave me the sure result that I was looking for, and I'll ignore the rest. So when I hit one of these situations, I know what the answer is, and it doesn't matter what the rest of the evaluation gives me. I can end the evaluation, number one, and then I can return the value that made it obvious what the return value would be. So keeping these two things in mind, for a particular type, the empty value is a representation of 0 or a false, and that short-circuiting occurs when the value is clear. So is 2 less than 3? Sure. What's the result of 2 or 3? Remember, 2 is a stand-in for true as well as 3, but OR only needs one true value. The first 2, which is a true value, is good enough to give me the answer, true, but instead of returning just true, Python returns a value 2. That was the value that made it clear what the result was. I returned that value. 2 and 3, I don't know what the answer is until I see all of the evaluations. A false in here would have gotten me where I wanted to go, but if I'm doing trues, 2 is a true, 3 is a true. Only at that point do I know the answer, 3. For an AND, the first false is enough to make it clear what the AND result is going to be. As soon as I see the 0, I know exactly what the result is going to be. It's going to be false. I return the value that made it false, 0.